الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the first lecture in Math 113 Calculus 2. We continue Calculus 2 from the same book in which we studied Calculus 1, which is the 9th edition of the book of Stewart and others called Calculus Early Transcendental Functions. We continue from chapter 5. We studied 4 chapters in Math 111, and now we continue from chapter 5, which is about integrals. In section 5.1, we will discuss the area and distance problems, and we will concentrate on the area problem. So for the area, we know the area of some known figures. For example, a rectangle like this, the area would be the length times the width. Area is L times W. For a triangle, the area is half times the base times the height. Okay. For a polygon like this, we can divide this polygon into triangles, and we find the area of each triangle, and we add these areas to get the area of the polygon. So we can find the area if we have straight lines like this. But if we have a curve, if this is a function, this is a graph of a function f of x from A to B. So now we have this region S, and the question would be, what is the area of this region? Okay, how can we find the area of this region? So let us start by this example. Use rectangles to estimate the area under the parabola y equals x squared from 0 to 1. Okay, this is the graph of the parabola y equals x squared from 0 to 1. So we need to estimate the area of this region S. How can we do that? Well, we can, for example, divide this distance from 0 to 1 into 4 small strips. Okay, so for example, the area, or it is from 0 to 1, so the length is 1. The length is 1. So if you divide, and I can say that if I say that delta x is b minus a over n, where delta x is the width of the rectangle, So b is 1, this is b, a is 0, over n, the number of rectangles. I have 4 rectangles, so the width is 1 over 4. So this width is 1 over 4. So the first interval would be from 0 to 1 over 4. Then you add another 1 over 4. So the second interval would be from 1 over 4 to half, and so on. So I have 4 regions, but how can these are not rectangles. S4, for example, is not a rectangle. So how can I make it a rectangle? Well, I have 2 choices, either to graph a horizontal line from the right end points or from the left end points. So let us talk about the right end points first. So for example, this is S4. This is S4. To make it a rectangle, we draw a horizontal line from here. So this would be a rectangle. It's greater than S4, but it's okay. We need to estimate the area or approximate the area. So here we Continued, we draw 4 rectangles using the right end point. So I can say that the area of S is approximately, well, in fact, it is less than here because I can see that the rectangles are greater than the area. So S is less than the area of S1 plus the area of S2 plus the area of S3 plus the area of S4. So let me call it A, and uh, the area of S1, let me call it A1 plus A2 plus A3 plus A4. Well, the area of S1 is a rectangle, okay? So what is the area of a rectangle? We have seen it is the width times the length. The width is always 1 over 4. So the width in the 4 rectangles is always 1 over 4. So we can take 1 over 4 as a common factor. Now, what is the length of the first rectangle? Well, this is the length, which is in fact f of 1 over 4. If we are using the right endpoint, it is f of 1 over 4. This height is f of 1 over 4 plus f of half. Okay, this is f of half. This point here, you can find it here. This is f of half plus f of 3 over 4 plus f of 1, which is 1. So we know that the height here is 1 because 1, 1. F of 1 is 1. So this is 1 over 4, okay, times. Now what is f of 1 over 4? Well, f, the definition of f of x equals x squared. So f of 1 over 4 would be 1 over 4 squared, okay, plus 1 over 2 squared plus 3 over 4 squared plus 1 squared, which is 1. So if you add these numbers using the calculator, it is 1 over 16 plus 1 over 4 plus 9 over 16, which is plus 1. So the answer is 15 over 8. And if you multiply by 0.25, the answer is 15 over 32, or approximately exactly, in fact, 6875. So I can say that the area of S is less than or equal to 0.46875 using 4 rectangles. This is a very nice result. Now, if we use the left end point, so instead to be the height of the rectangle, so the height of the first rectangle, f of 0. Well, f of 0 is 0, so there is no rectangle here. The second rectangle, the height is f of 1 over 4. The third rectangle, f of half, is the height. And f of 3 over 4 is the height of the fourth rectangle. In this case, we can see that the area of S is in fact greater than, okay? It is not less than or equal. It is less than, in fact, because we can see that, okay? It's greater than. Here it's less than because the rectangles are greater than the area, while here the rectangles are less than the area. So the area is greater than, again, 1 over 4 is the width of the 4 rectangles, but the heights or the length are f of 0, which is 0. This is the first rectangle. F of 1 over 4, f of half, and f of 3 over 4 is the height of the last rectangle. So This is 1 over 4 times f of 0 is 0. F of 1 over 4 is 1 over 4 squared. 1 over 2 squared. 9 over 16. So you can evaluate this. This is 4 over 16, 14 over 16, in fact, times 1 over 4. So the answer is 7 over 32, or exactly 0.21875. So I can say at the end that the area is greater than 0.21875 and less than 0.46875. So using 4 rectangles, dividing this region into 4 areas and then making rectangles using the left endpoint or the right endpoint, I can estimate the area that the area is between 0.22 and 0.47. And that's an excellent result. Imagine that you don't use 4, you use 8 rectangles, okay? 8 rectangles. You will get uh, uh, a better approximation if you use more rectangles. For example, 8 rectangles, okay? Now another example. For the region, the same region, show that the approximating sums Rn using the right endpoint approaches 1 over 3. That's limit Rn when n goes to infinity is 1 over 3. So what is Rn? Rn means we will divide into n rectangles. We will divide this region into n strips, and then we use rectangles, okay? And we will use endpoints, right endpoints. So we will have n rectangles, and now what is delta x here? What is the width of each rectangle? It is b minus a, which is 1 minus 0, because from 0 to 1 over the number of rectangles, which is n in this case. So we have 1 over n. 1 over n is the width of all the rectangles. Now, what about the height? Okay, we will use the right end point. So you can see that the first interval is from 0 to 1 over n. The second interval is from 1 over n to 2 over n, because you just add 1 over n. The third interval is from 2n to 3n, and so on, okay, until you reach 1, the last one. So we will have f of 1 over n, which is the right endpoint. This is the first rectangle. This is the length of the first rectangle, plus f of 2 over n. This is the length of the second rectangle, and so on until we reach f of 1, which is the right endpoint of the last rectangle. Now, this is 1 over n times. What is f of 1 over n? Again, this is 1 over n all square, okay, all square. 2 over n, it is 2 square, okay, which is 2 square over n square. 3 over n, 3 square over n square, plus up to 1, okay. This is what is 1 in fact? It is n square over n square. You can write 1 as n square over n square. 1 is n over n. Good. So I can write it 1 over n, and I can take 1 over n square as a common factor from all of these terms. So inside I will have 1 plus 2 square plus 3 square plus up to n square. So now I have 1 over n cube here. N times n squared is n cube. And what is this? So here comes this fact. We can prove this easily using mathematical induction or other uh, types of proofs. This is a famous formula. Adding 1 square plus 2 square plus 3 square up to n square is equal to n times n plus 1 times 2n plus 1 over 6. So I can replace this sum by n times n plus 1 times 2n plus 1 over 6. So what is Rn at the end? It is, you can say, n times n plus 1 times 2n plus 1 over 6n cube. Okay, if you want, you can cancel this n with one of the n's here below, and you write it in square. Okay, so you cancel this n with one of the three n's in the denominator. Okay, this is Rn. Now, what do we need to prove? We need to find limit Rn when n goes to infinity. So let us find the limit when n goes to infinity of n plus 1 times 2n plus 1 over 6n squared. If you remember, to find the limit when n approaches infinity, there is an easy way to deal with that by taking the highest power, the term with the highest power in the numerator. That's 2n squared. If you multiply these two parentheses, the highest power would be n times 2n squared over 6n squared. So n squared cancels with n squared, and you have 2 over 6. Uh, and the limit of 2 over 6 when n approaches infinity is just 2 over 6 or 1 over 3 because there is no n here. So this is the proof that the limit of Rn when n goes to infinity of 1 over 3. And this means that if you take infinite number of rectangles, then the area of this region would be 1 over 3. So by introducing the limit, by finding the limit of the area of the n rectangles when n goes to infinity, so infinite number of rectangles, we can find the area, which is 1 over 3. So that's the area of this region. It is exactly 1 over 3. Uh, pay attention to this point. If you deal with the right end points and the function is increasing, so always you will have an upper estimate, which means your estimate would be greater than, higher than the area, the actual area, because the function is increasing and the rectangles would be always above the area, the region. The left endpoints, when the function is increasing, will give you always a lower estimate. So the actual area would be less than, would be greater than, sorry, the 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 sum of the areas if you use the left end points. Well, let us generalize this region. Let us talk about any region S comes from any function, and let us divide this region into n strips from S1 to Sn. Now, as we have seen, the width of each strip would be delta x, which is b minus a over the number of strips, which is n. So b minus a over n, that's always will give you the width of the strip, and it would be the width of the rectangle. And you have these intervals, AB, the interval AB, would be divided into these intervals from x0 to xn, x0, x1, x1, x2, and so on, where x0 is A and xn is B. Well, how to find x1? X1 would be, this is x1, would be A plus the width, which is delta x. So x1 would be A plus the width, delta x. How to find x2? It is A plus 2 delta x, and so on. So how to find xi in general? What is xi? It is A plus I times delta x. Okay, so this is how we find xi. It is A plus I times delta x. So we can write a formula. This is the known formula which we used for Rn. So Rn is using the right end point, the sum of the area or areas of the n rectangles. F of x1 times delta x, this is the length of the first rectangle. This is the width of the first rectangle. This is the length of the second rectangle, and so on. You notice that the width is the same, so you can take it as a common factor. Okay, so this is delta x is always the same, and f of x, you start by f of x1 because you use the right endpoint, then f of x2 up to f of xn. So when you use the right endpoint, you start from x1. Okay. Notice that if you increase n, when you increase n, you get a better approximation. So if you take n to infinity, you will get the area, the actual area of S. So the definition of the area would be it is the limit of Rn when n goes to infinity, where Rn is given by this. If you use the left endpoint ln, you will get the same result. It would give you also the area, but notice that you will not start by f of x1, you will start by f of x0 because you take the left endpoint. So you start from x0 and you end up at xn minus 1, not xn. Okay, so this is when you use the left endpoints. Or in general, you can take the midpoint or any number in the middle between x0 and x1. Let us say x1 star. So A would be, in general, the limit of these sums, f of x1 star delta x plus up to f of xn star times delta x. Let us remind ourselves with the sigma notation. Okay, if you remember the sigma notation, we can, delta x here is a common factor, we can write it. F of x1 plus f of x2 plus up to f of xn, you can write it f of xi, where I runs from 1 to n. Okay, so we can replace these n sums, n terms, by this one. So this tells us to add this one, the summation. Okay, n tells us to end with I equals n. M tells us to start with I equals m. So we start by I equals m, we end by I equals n, and we add. This is the meaning of sigma notation. So we can rewrite the area like this. It is the limit of f of xi delta x. If you start from 1, this is the right endpoint. If you start from 0, from 0, okay, you write it f of xi, or if you write it f of xi minus 1, and you start also from 1, so this would be the left, this is the right, and this is the general one. Okay, f of xi star times delta x, where I is from 1 to n. So this is I. Okay, this is I. We also, do you remember the formula, which is 1 square plus 2 square plus up to n square equals this? So this summation is equal to what? I start by I equals 1. 1 square plus 2 square plus 3 square up to n square will give you this one. Let us see this example. Let A be the area of the region that lies under the graph of this function between 0 and 2. Well, the graph of e to the power negative x is like this, and from 0 to 2, okay, this would be the region he's talking about. So using right endpoints, find an approximation for A as a limit. Do not evaluate the limit. So A is the area. A is the area of this region. So find an approximation of A as a limit. So A equals, find an expression for A as a limit. A would be limit something, one of these. So if we use the right endpoint, it would be the first one. So A would be limit, this would be, so you need to memorize these formulas. It is the limit from n to infinity of summation I from 1 to n f of xi times delta x. So this is what we need to write, okay, using right endpoints. Good. Let us start with delta x. What is delta x? Delta x is b minus a over n. Well, b is 2, a is 0, from 2 to 0 over n. So delta x is 2 over n. Good. What is xi? If you remember, xi is a plus I times delta x. We have just seen this. So what is a here? A is 0 plus I times, what is delta x? 2 over n. So in fact, xi is 2I over n. Good. Now what do we need to do? We need to find f of xi. So what is f of xi? Well, f of xi would be, f of x is e to the power negative x. So to find f of xi, you replace x by xi. So it would be e to the power negative xi. That's f of xi. All right. Uh, but then what would be xi is 2I over n. That's xi. So f of 2I over n would be e to the power negative 2I over n. Okay, so this is, so I can write a as limit when n goes to infinity, summation I equals 1 to n, f of xi, which is e to the power negative 2I over n times delta x, which is 2 over n. That's the answer. Okay, you can take 2 over n outside because here, for example, because it has no I, or you can just leave it like this. So this is an expression. Do not evaluate the limit. Actually, uh, we cannot, or we will not find the limit because he just needs this. Estimate the area by taking the sample points to be midpoints and using 4 subintervals and then 10 subintervals. I will do the 4 subintervals and you can do the 10 subintervals, just needs more time. So 4 subintervals, this means that n is 4. So delta x in this case would be b minus a, which is 2 minus 0 over 4. So it's 2 over 4 or half. So this means that this is half, and then another half 1, and this is 3 over 2, and this is 2. Okay, so I have the intervals. We have from 0 to half, the first interval, half to 1, the second interval, and so on. The width is also half. But what about the height? Which now are we using right or end? No, we're using right or left? No, we're using midpoints. Midpoints. Okay, so I need to find the midpoint between 0 and half. So let me say that, let me make this table for the sake of illustration. The first interval is from 0 to half. The second one is from half to 1. The third one is from 1 to 3 over 2, and then from 3 over 2 to 2. Now, what is the midpoint? Okay, or in fact, what is xi? Okay, in this case. Well, the mid number between 0 and half, how to find it? It is 0 plus half over 2. That's the way you find the mid number. So it's 1 over 4. Here you add 1 plus half over 2. So you get 3 over 4. Or, okay, so it's 1 over half over 2, which is 3 over 4. Or it is in fact 1 over 4 plus the width. Okay, because if you start from here, this is 1 over 4, and add half, you will get to this point, another half this point. So to find all the midpoints, you just add 1 over half. So now you have 3 over 4. If you add another half, you get 5 over 4. Another half, you get 7 over 4. Okay, so these are the midpoints, the mid values of x. Now, we need to find what f of these values. Okay, so f of 1 over 4. What is the function here? It is e to the power negative x. So this would be e to the power negative 1 over 4. Okay, f of 3 over 4, e to the power negative 3 over 4, e to the power negative 5 over 4, e to the power negative 7 over 4. What are these? These are the heights of the rectangles. Now, what would be the area estimated by M4? So A is estimated by M4, which is the sum of the four rectangles using the midpoint. Okay, this is equal to the area of the first rectangle. What is the area of the first rectangle? The width times the length. The width is always half, so I can take half as a common factor. What is the height of the first rectangle? It is e to the power negative 1 over 4. The height of the second, the height of the third, the height of the fourth, and you can put these in the calculator and find the number. This will give you the area approximation of the area. You can try using 10 rectangles. You will find a better approximation than this if you use 10 rectangles. Okay, just do the same. Just here divide by 10, and you will have 10 intervals. Find the midpoint of each one, the height of each rectangle, and then write the area. This is the end of this section. I hope it's clear.